Every fundamental law of physics works exactly the same, forward or backward in time. Except one. Play a video of two atoms colliding. Run it backward. It still looks correct. Nothing about it breaks any law. Now play a video of an egg cracking on a kitchen floor and reverse that instead. It looks like a magic trick. Shell fragments leap upward. Yolk reassembles inside a shell that seals itself shut. Somewhere between the clean mechanics of a single atom and the sudden collapse of an egg, the universe started demanding a direction. That demand has a name, and that same demand is the reason your body is losing a war it can never win. The reason every cell in you is aging one way and only one way right now as you watch this. Here's the part almost nobody tells you. Physicists cannot explain where that direction actually comes from. The law that guarantees your death has no confirmed origin. By the time this ends, you'll understand why the smartest physicists alive still can't answer the one question your own body asks every single day. Picture a coffee cup on your desk at 9 in the morning. It's hot enough to fog the air above it. You get pulled into an email, a phone call, a conversation down the hall. By the time you come back, it's noon, and the coffee is cold. Not lukewarm, cold. The kind of cold that tastes like a mistake. You don't find this strange. You've watched it happen 1,000 times, in 1,000 cups, and it has never once surprised you. Heat leaves. It moves from the hot coffee into the cooler room, spreads out and disappears into the air until the cup matches its surroundings. But now imagine the opposite. Imagine walking back to your desk at noon and finding the coffee hot again. Steam curling up off the surface, heat pulling itself back out of the room and concentrating itself of its own accord into your mug. You'd assume someone microwaved it. You would never for 1 second assume the room did it by accident. And you'd be right to assume that, because in the entire observable history of the universe, it has never happened. Not once. Not to a single cup of coffee, anywhere. Here's the strange part. Nothing in the fundamental equations that describe the atoms in that coffee forbids it. Zoom in far enough, down to the individual particles bouncing around in that mug, and their motion is completely reversible. Every collision, every exchange of energy works exactly the same whether you play it forward or backward. And yet the coffee never reheats itself. Never. That single, unremarkable fact, one you've watched happen your whole life without questioning it, is hiding one of the deepest unsolved problems in physics. It is also, quietly, the reason you will die. But nobody stops to ask why. We've built an entire cultural instinct around the coffee cooling. Go make a fresh pot. Don't waste time waiting for magic, without ever asking the question sitting directly underneath it. If the individual atoms don't care about direction, why does the cup? This isn't a small technicality. It's the same question hiding behind everything that ages, everything that decays, everything that eventually stops. Your skin losing elasticity, a star burning through its fuel, a civilization collapsing into ruins that archaeologists dig up centuries later. All of it obeys the same one-way rule the coffee obeys, and none of the fundamental laws governing the particles underneath any of it actually require that rule to exist. The real question, the one that breaks everything wide open, is this: what gives time a direction when nothing at the smallest scale of reality seems to want one? Physicists have a name for this. They call it the arrow of time. And here's the part that should genuinely unsettle you. It isn't fully explained. Not by relativity, not by quantum mechanics, not by anything in the standard toolkit of modern physics. There is a rule that reliably predicts which way time flows for coffee, for stars, for you, and nobody has ever proven from first principles why that rule exists at all. The answer physics gives you next sounds airtight. It is not. And once you see the crack in it, you won't be able to unsee it, in your coffee, in your body, or in the universe itself. The textbook answer is called the second law of thermodynamics, and on the surface, it's beautifully simple. Entropy, a measure of disorder, or more precisely, the number of ways a system's particles can be arranged while still looking the same from the outside, always increases in a closed system over time. Heat flows from hot to cold because there are vastly more ways for that energy to be spread out evenly than concentrated in one place. Your coffee cools because a cooled, evenly distributed cup of coffee in room is simply a far more probable state than a hot cup sitting in a cool room. This law, physicists will tell you, is the most stubborn, unbreakable rule in the universe. Einstein reportedly called it the one physical theory he was convinced would never be overturned. Every engine, every living cell, every star obeys it without exception. And your body is no different. You are, biologically, an extraordinarily ordered structure. Trillions of cells, each one a small miracle of organized chemistry, constantly fighting to maintain that order against the relentless statistical pressure toward disorder. You eat, you breathe, you repair damaged tissue. All of it work spent holding entropy at bay for one organism, for one lifetime. But the second law always wins eventually. Repair mechanisms slow. Errors accumulate faster than they can be fixed. Order loses ground to disorder, cell by cell, year by year, until the system can no longer sustain itself. That, in one sentence, is why you age and why you will die. Because entropy always increases, and no living system can outrun that increase forever. It's a clean explanation, complete sounding, the kind of answer that closes a question rather than opening one. But there's a detail buried inside this explanation that most people never look at directly. A detail that, once you notice it, makes the whole tidy story start to wobble. So the textbook says entropy always increases, full stop, an unbreakable law of nature. But the universe does something far stranger. It doesn't actually explain why entropy was ever low enough to begin with for this whole story to work. Here's the contradiction hiding inside the clean explanation. The underlying laws of physics, Newton's laws, Maxwell's equations of electromagnetism, even the Schrödinger equation of quantum mechanics, are all what physicists call time-symmetric. Run any of them backward, and they remain perfectly valid. There is nothing in the fundamental mathematics of a single particle that prefers one direction of time over another. The one-way arrow only shows up when you zoom out to huge numbers of particles. And even then, it only works because the universe apparently started in an almost unimaginably ordered state. Physicist Roger Penrose actually calculated the odds of the universe beginning in a state that low entropy by pure chance. The number he arrived at was roughly 1 in 10 to the power of 10 to the power of 123, a number so large that writing out all its zeros would require more digits than there are atoms in the observable universe. That number isn't a rounding error. It's a sign that something is deeply unexplained. Entropy increases now because it was somehow absurdly, impossibly low at the beginning of time, and nobody has a confirmed reason why. This is called the past hypothesis, and it is, quietly, one of the most significant unsolved problems in all of physics. We don't derive the arrow of time from deeper laws. We simply observe that it's there, trace it back to the universe's starting conditions, and hit a wall of silence where the explanation should be. Which means the law responsible for your aging, your decay, your eventual death, the law Einstein called unshakable, rests on a foundation nobody has ever actually proven. You are not dying because physics demands it. You are dying because the universe happened to start in a state so improbable that physicists still don't know why. And you were born downstream of that improbability. Picture this. You're standing alone in a quiet room, and on the table in front of you sits a wine glass. You reach out, nudge it slightly, and it tips off the edge. It hits the floor and shatters, dozens of fragments skidding in every direction, a fine mist of glass dust settling in the light. You crouch down and look at the mess. Ordinary, unremarkable, the kind of small accident that happens in kitchens every day. Now imagine someone hands you a remote control with a single button on it. Rewind. You press it, and the fragments on the floor begin to tremble. They slide back across the tile, gather themselves at a single point above the floor, fuse seamlessly along invisible seams, and rise, reassembling into a perfect, unbroken wine glass that settles gently back onto the table exactly where it started. Here is the unsettling part. Nothing about that rewound sequence breaks a single law of physics at the level of individual atoms. Every collision, every energy exchange is just as mathematically valid running backward as it was running forward. If you only had the equations governing each fragment, you could not tell which direction was the real one. And yet you know, instantly, without a second of hesitation, that the rewound version is the fake one. Every instinct you have screams that glasses do not unshatter. That instinct isn't wrong, but it isn't coming from a fundamental law of physics either. It's coming from probability, stacked so extraordinarily high against reassembly that in the entire history of the universe, it has essentially never happened by chance. Now apply that same logic to yourself. Every cell in your body, every strand of DNA, every neural connection, all of it is a version of that wine glass, astonishingly ordered, statistically improbable, held together against overwhelming odds by a constant expenditure of energy. And exactly like the glass, the moment that maintenance stops, the odds reassert themselves. Not because a rule demands your destruction specifically, but because the universe you happen to exist in was set up at its very beginning in a state so ordered that disorder was always going to be the only way forward from there. You are not fighting a law that targets you. You are living inside the tail end of a fluke so large no one has explained it. And your body is simply where that fluke is currently unwinding. If the universe's arrow of time only exists because it happened to start in an absurdly ordered state, does that make death a fundamental law, or just an accident of when and where you happen to exist? What you're about to learn next is the part even physicists find genuinely disorienting, because the deeper you go, the less death looks like a rule, and the more it looks like a number. Think back to that wine glass reassembling itself. The reason it felt impossible wasn't a law forbidding it. It was a number so lopsided that impossible became the honest way to describe it. Here's the intuitive version, and it starts with a deck of cards. Shuffle a brand new, perfectly ordered deck, ace through king, all 4 suits in sequence, and after just a few shuffles, that order is gone. Not because shuffling has some magical destructive power, but because there is exactly one way for the deck to be perfectly ordered, and there are roughly 80 unvigintillion, that's an 8 followed by 67 zeros, ways for it to be shuffled into disorder. You're not fighting a force when you shuffle a deck. You're just landing, overwhelmingly, in the more common outcome. That's the whole idea, scaled up to the level of atoms. Physicist Ludwig Boltzmann gave it precise mathematical shape with an equation carved on his own tombstone. S equals K log W. In plain English, the entropy of a system, S, is proportional to the logarithm of W, the number of different microscopic arrangements that all produce the same macroscopic appearance. A tidy room has very few arrangements that still look tidy. A messy room has an almost uncountable number of arrangements that still look messy. Low entropy is rare. High entropy is common. That's it. That's the entire engine behind aging, decay, and death, not a force pushing you toward disorder, but the plain statistical fact that disordered states vastly, vastly outnumber ordered ones. And here's the fundamental layer, the one that reframes everything you thought you understood about your own mortality. Death is not a punishment written into the fabric of the universe. It's not a design flaw, and it's not a force actively working against you. It is what happens, with near mathematical certainty, to any sufficiently ordered structure existing inside a universe that began in an improbably ordered state and has been unwinding toward probability ever since. You are not being destroyed by physics. You are returning to statistical equilibrium, and the only reason that return feels so personal, so specific to you, is that you happen to be one of the rare, ordered structures currently making that journey. That statistical unwinding, the return from rare order to common disorder, doesn't stop at the edge of your body. It's running, right now, at every scale of existence. Zoom all the way in to a single radioactive atom sitting inside a rock. There is no way to predict the exact moment it will decay. Quantum mechanics only gives you a probability. But zoom out to trillions of those atoms, and the pattern becomes as reliable as a clock. A fixed half-life, a steady statistical unwinding from an unstable, ordered nuclear state toward a more stable one. The same arrow, running at the atomic scale. Pull back to your own scale, and it's the same story wearing a different face. Cells accumulating small copying errors every time they divide. Repair systems slowly losing the statistical battle against damage, until the astonishingly ordered structure that is you can no longer maintain itself against the tide. Pull back further to the scale of a planet. Earth itself is a temporary pocket of order, built entirely on borrowed time from the sun. A star steadily converting its ordered nuclear fuel into heat and light, unwinding its own store of low entropy at a rate of about 4 million tons of mass per second. In roughly 5 billion years, that fuel runs out, and the ordered structure we call a stable solar system unwinds along with it. Now pull back to the largest scale physics can describe. Every star in every galaxy is doing exactly what your sun is doing, burning down a finite reserve of order. Astronomers already have a name for the era we live in, the stelliferous era, the age of starlight. And by current estimates, it represents only a narrow window in the far longer lifespan of the universe. Trillions of years from now, the last stars will exhaust their fuel. Even black holes, the densest concentrations of order in the cosmos, will eventually evaporate away into faint radiation through a process called Hawking radiation, over timescales almost too large to write down. The endpoint physicists call this is heat death, a universe so evenly spread out, so thoroughly at equilibrium, that no further change, no further order, no further you is possible. The same arrow, the same statistical unwinding, running in a single atom, in a human body, in a star, in the universe itself. All of it the same story, told at wildly different scales, and all of it tracing back to that same improbable, unexplained beginning. Pull all of that, the atom, the body, the star, the entire unraveling universe, back down to the chair you're sitting in right now, and something remarkable comes into focus. You have spent your whole life treating death as something that happens to you specifically, a personal ending, a biological malfunction, or a cosmic injustice, arriving for you and you alone. But it isn't personal at all. It's structural. It's the same arrow that cools your coffee, burns down your sun, and will eventually spread the last black hole into a whisper of radiation across an empty universe. You are not being singled out by some cruel design. You are a temporary knot of extraordinary order, tied at a moment in cosmic history when order was still statistically available to be tied into something, and every knot, without exception, eventually comes undone. And here's the part that should genuinely stop you. Physics can describe that unraveling with perfect precision, the equations, the timescales, the exact statistical mechanics of it, while having no confirmed answer for why the knot was ever tied in the first place. Nobody has proven why the universe started so ordered that any of this, stars, cells, you, was ever possible at all. Which means the thing you've spent your whole life fearing isn't the villain in the story. It's the story's grammar. Death isn't physics breaking a promise to you. It's the same rule that let you exist in the first place, simply running in reverse. And the honest, almost unbearable truth is that no one, not even the most brilliant physicists alive, can tell you why that rule exists at all. Sit with that for a second, because it changes the shape of the question you actually want answered. If the arrow of time, the thing responsible for aging, decay, and every ending you will ever witness, depends entirely on an initial condition of the universe that nobody has explained, then death isn't a law handed down from on high. It's a consequence of a starting point that could, in principle, have been different. Which raises a question with no comfortable answer. If a future version of the universe were ever to reach a state as improbably ordered as its beginning, through some process we don't yet understand, would time's arrow reverse for whatever existed inside it? Would something, somewhere, experience its ending as its beginning? Nobody knows. Some physicists take the past hypothesis as a brute fact, a starting condition you simply have to accept without further explanation. Others suspect it's a clue, pointing toward a deeper theory we haven't found yet, something that would finally explain why the universe began so ordered, the way general relativity eventually explained why apples fall. Until that theory arrives, you're left in a strange position. You can describe, with total scientific precision, every mechanism by which you will age and die. And still, underneath all of that precision, sits a single unanswered question. Why did any of this, order, time, you, begin at all? Picture a candle burning on a table in a dark room. Wax runs down its side, pooling and hardening in uneven layers. The flame eats through the wick, inch by inch, converting stored, ordered chemical energy into scattered heat and light that drifts off into the dark room and disappears. Nobody watching that candle feels shocked by what's happening. It's simply what candles do. It's simply what flames do. It's simply what time does. You are that candle, not diminished by the comparison, illuminated by it. Every ordered, improbable thing about you, your thoughts, your memories, the specific arrangement of atoms that lets you understand this sentence, is light, briefly held together, spending itself against a universe tilted toward the dark. And somewhere, underneath all of it, sits a question no equation has ever closed. Why was there a match to strike in the first place? Rewind that billiard ball again if you want. It'll still look correct. But you already know, now, exactly why the flame never will. If that question is still sitting with you, there's a whole universe of them waiting here.